Hi-oh, here we are. We're going to solve a series circuit, a basic series circuit. In the picture you can see we have a resistance of we have a resistance of 1 ohm in this resistor, and we'll call that resistor 1, and this is resistor 2 and resistor 3, and of course this is point A, point B, point C. The battery is supplying 12 volts. From that, we could figure out all sorts of things. The total resistance, the current at every point, the total current, the voltage drop. If you remember, voltage drop means how much basically the voltage across any particular area. Or in other words, the voltage change, because remember, it starts at a high potential and goes to a low potential. We could do all that stuff. But I prefer just to not even consider these questions and just answer everything I can about the circuit, and then go back and answer the questions. So let's see, what can we do? I like to go about it, and I say, well, what can I find? Is there anything that I can find from this? Well, do I know the current any place? No, don't know the current any place, so I can't find the current anywhere at this point. I know one voltage, which is 12 volts. I don't know the voltages everywhere. I know that when we add up those voltages, it should equal 12 volts. Okay? Total resistance. Let's see. The resistance is the sum of all the resistors. I can do that. So resistor 1 is 1 ohm. Resistor 2 is 2 ohms. Resistor 3 is 3 ohms. So the total resistance is 6 ohms. So the resistance total is 6 ohms. And one way to go about doing this is shrink things down. Turn this complicated thing into a single resistor. This battery, this 12-volt battery, doesn't know how many resistors there are. It knows that there is 6 ohms of resistance. So I'm going to put that this battery feels 6 ohms of resistance in the original picture. Well, from that, let's see, we know a voltage, we know a resistance. Look at that. Voltage, resistance. We could certainly find the current being supplied by that battery. So let's see. V is 12, I is what we're solving for, R is 6. So the current must equal 2 amps. So look at this. It's 2 amps supplied by the battery. Notice I'm labeling the drawing over and over again. Well, look at that. So I know the resistance everywhere. I know that the current at the battery, coming from the battery, is 2 amps. But I also know that if I know the current anywhere, I know it everywhere. So look at that. 2 amps going through here, 2 amps here, 2 amps here, 2 amps there, 2 amps, 2 amps, everything is 2 amps. The only thing left to really solve for is voltage. And the voltage, very simply, is the sum of all these. Well, what are these voltages? I think I would want to use V equals I times R, Ohm's law. If we look at the first resistor, we know the current is 2 amps, and we know the resistance is 1. So the voltage must be 2 volts. Oh, there we go. The second one, the current is 2 amps, the resistance is 2, therefore looks like 4 volts. And over here, it must be 6 volts. That should add up to 12. 2 plus 4 plus 6 gives us 12. Checks out. I've solved everything about this problem. Shoot, we could even find the power, right? Power is current times voltage. We know the current someplace. Let's say the battery. The current is 2. We know the voltage of the battery. So look at that. It's a power output of 24 watts. There were a couple other questions that we did not address, and that was the last 3. If by adding another resistor, what happens to the voltage? Well, think about this. if adding another resistor, so now we have another resistor right here, let's say it's 4 ohms. What happens to the voltage across any of these other ones? Well, we know when we add up all these voltages, it has to equal 12. This one now needs some voltage, which means the others will become less. What happens to the current? Well, as we add resistance, in fact, probably easier to answer this last question first. What happens to the total resistance? Well, in a series circuit, right, the total resistance is the sum. So add up those resistors. Looks like we added more resistance. That increased. So what happened to the current? We know Ohm's law, I equals V over R. What happens if we increase the resistance? The current decreases. And there you have it.